Assalamualaikum, salam sejahtera, and good day to you. My name is Muhammad John Arif bin MULIADEE, and we are the Quaran team. What we've come up for this project is called the Efficiency-Based Watering System, or EBWS for short. This system aims to help farmers conserve their energy by cutting down on the labor-intensive task of watering crops. It also aims to maximize water-saving potential by utilizing rainwater as a replacement for tap water. This system is particularly useful for farmers who have trouble getting through the day doing labor-intensive tasks around the farmstead. Note that this system can only be applied in places where rain can occur, and its design is built specifically for greenhouses. Now that you're all caught up to speed, my teammate, AMIR, will further elaborate on the build of this system. Take it away, AMIR.
Thank you, Johan. The seamless equipment that we use is one button, one RGB LED, two servos, two proximities, and two motors. Now I'm going to explain on how the build works. So, when the rain falls, it will flow on this roof and into our gutter here. So from our gutter here, the water will flow under this small pipe hole that will flow directly into our tank here. Now, from our tank here, let's open this. There is a filter where they will filter like a block any leaves or something unusual. And there's also a buoy that will sense the proximity sensors when it reaches maximum water level. When it did, from here, the servo here will close like a door will close, and to quit any overflowing and also keep the water clean. When it does overflow, we have a small pipe here that will flow the overflowing water into the ground. When the water tank is full, the RGB LED will turn into green, indicates that we have enough water to water our plants. So we can push our button here. And this motor will spin like a fan, so it will pull the water through the pipe here and into our plants. As you can see, all the plants here has its own individual pipe, so there is no human contact and it's fully automatic. Now my other teammate, AMIR ZAHIN, is going to explain on how the coding is going to be.
Alright, thanks to AMIR for elaborating on the design of this system. Now, the proximity sensor, which will measure how far the block is by giving an input between 0 to 100. Then the input will break down into 3 outputs, which will be the LED, RGB LED, the 2 motors, and 2 servos. First, the RGB LED. Red means there is less water in storage, input ranging between 96 and 100. Okay, now green is when the water in the storage is full, input ranging between 0 to 16. That means the block is very near to the proximity sensor. Now yellow, measuring between 16 to 95, means there is water but not enough to water the plants. Second output, the motors. First, the motor will act like a water wheel or some sort, and there will be 2 inputs to activate the 2 motors for 10 seconds. Yeah, ranging between 0 to 16 input. Then the 2 servos, also ranging between 0 to 16 to open the latch for the water to come in. Thanks, that's all from me. Now for the True by John Arif.
In conclusion, we think that if this system were to be easily accessible to farmers, it would surely improve on the efficiency of harvesting crops by a large margin, and it would also help benefit our economy. To support that notion, SamLab should add a moisture sensor, as the possibilities of that sensor would be endless, and surely be a great addition to the sensor lineup. Lastly, we would like to give a huge thanks to our teacher, PUAN IZAWATI, for giving us this opportunity to join this competition. We hope to see you again. Bye!